Hello, everybody, and welcome to this online lecture for Geography 178 for the 19th of October, 2023. Um, Thank you for bearing with me as I'm currently probably in Madison, if you're watching this right as it opens at 9:30. Appreciate you bearing with me as I'm traveling to a conference with a bunch of other professors and students from the Geography and Anthropology department. We're hopefully having a good time. Uh, One quick thing before we dive into the lecture here. I would advise as you're moving through this, because I don't really take the same types of pauses and breaks and T-sips that I would during normal class period to let you all finish writing. When I advance the slide, pause the video, write everything down that you would need, or as I'm advancing, pause the video and write things down, and then continue on. Like I said, I'm not really slowing down to let you all finish writing because you can just pause me and then probably put me back on 2x speed. Totally fine. I get it. I'm sometimes boring to listen to. I recognize that. But anywho, we're going to dive right into it with looking at our snapshot. Here's just a quick snapshot of our week. Obviously, nothing's really changed. You're going to keep working through your chapters 13 and 14 if you're reading along in the book. Thinking Like a Mountain, make sure you're reading through that and make sure you've watched Green Fire, because as for upcoming due dates, you still have your class connection as normally scheduled despite my absence. You have your reading quiz due on the 20th, so tomorrow at 11:59 p.m. As well as your think piece. Last I checked, there weren't a whole lot of think pieces submitted, so make sure you're working on that. And then your concept application assignment number 3, which is just another short CAA, is going to be due this coming Monday, 11:59 p.m., the 23rd of October. So in the last couple of lectures, we've been talking about this concept of our atmosphere. We're going to be talking about the atmosphere, the hydrosphere, and the biosphere for the next good number of weeks within our course here. So the atmosphere is what we determined or defined as Earth's system of weather and climate. We talked about how energy coming into that Earth atmospheric system really drives changes and deviations across our surface. How energy surpluses in some areas relate to energy deficits in others, and how those reactions and relationships drive weather. So today we're going to switch gears a little bit and we're going to start focusing on how humans modify our Earth atmospheric system. So how they impact that system of weather and climate. So before we dive into it, I want you to pause the video here, scroll down to the description below the video, and go ahead and click on that first link to open up a new tab. And you're going to be watching this video by Dr. Johansson, Climate Science, What You Need to Know. We would have watched this in class, but since we're not in class, you're going to watch it here. Once you've watched that video, we can ask the questions, how do humans modify our atmosphere? Well, the first way is through cellular respiration. We're breathing, right? Our cells are breathing. They take in oxygen, they give out carbon dioxide. We're modifying just through existence. We're modifying our atmosphere. And vegetation, through photosynthesis, we plant vegetation all over the place. A lot of times it's agricultural purposes, but trees, flowers, everything like that. We plant vegetation across the world. That has an impact on climate. So those are the first two ways. They're not the most prevalent, we'll say, when it comes to how things are modified, but there are two that we need to consider. Okay, so then we need to ask the question, how do humans adversely modify our atmosphere? And that's the big one, because that's what we're going to focus on for much of the rest of this lecture and a series of lectures down the road here. First way, by adding pollutants to it. What are pollutants? These are any substances in air, whether they be gas, solid, or liquid, that can be harmful to life. There are natural versions and there are artificial. The natural versions come in the things like volcanoes or wildfires, for example. We don't necessarily control volcanoes. That's not something we can do, but wildfires a little bit more different. I made and poked fun at people burning down national forests through gender reveal parties, which is one of the most asinine things I think I've ever heard of. And the fact that it's happened more than once is concerning. But there are natural wildfires and there are anthropogenic or artificial wildfires, ones that we start and ones that occur naturally. That adds uh, pollutants to the atmosphere in a number of different ways. Anthropogenic sources are the other way that we add pollutants to our atmosphere. Well, what do anthropogenic things come from? Coal-fired power plant, for example, is one of the major sources of pollution. Smokestacks, we have particulate matter, things that have been burned off of the coal. We also have nitrogen oxides, NOx, and sulfur dioxide, SO2, and mercury, Hg. These are what we call primary pollutants. Now, primary pollutants are ones that are just coming right out of whatever source is there. Secondary pollutants, ones we'll talk about in a little bit, are kind of combined and things that happen after the primary pollutants start mixing and reacting with other things in the atmosphere. So some other primary pollutants, particulate matter through exhaust, lead, unfortunately, carbon monoxide, CO, and more nitrogen oxides from things like transportation, and VOCs, or volatile organic compounds. These are some nasty things. We'll talk a little bit more about these in the future. With all of these come secondary pollutants. Now, I've briefly mentioned this when we talked on, I think it was Tuesday, about our troposphere and our stratosphere, and the stratosphere absorbing a lot of UV rays through ozone, or O3. We talked about ground level or tropospheric ozone. That's the bad stuff. That's what happens when we've got pollutants on the surface that are mixing with other things and absorbing that energy that's being given off by the surface, that's been absorbed from the sun and given back off. Kind of acts as a little oven right along where we live. Now, if we looked at how this works, we've got a number of different things at play here, right? We've got industrial processes, automobiles, trucks, non-road vehicles, generators. All these things are emitting nitrous or nitrogen oxides. We've got things like refineries, manufacturing, gas stations, lawnmowers, automobiles, trucks, and on-road vehicles adding volatile organic compounds. Mix those together, add a little bit of sunlight, and bake it, and you've got ozone. Things like photochemical smog. Places like Los Angeles, San Francisco, Beijing, all these areas you often see concerns over things like smog advisories. And that's what it is all these human activities are basically giving off this disgusting combination of nitrogen oxides and VOCs that lead to very harmful air. There's a lot of times breathing warnings whenever you have this strong development of photochemical smog. You'll see these ozone advisories out just along the highways. One way to think about the differences here, because we've talked about ozone in good ways and bad ways, is that ozone is good up high, bad nearby. This is through the Santa Barbara County Air Pollution Control District. Just a nice little device to kind of remember this concept. So in the stratosphere, it's good. It protects Earth from the harmful UV radiation from the sun. At ground level, it's bad. It's harmful to plants. It's harmful to our lungs. We don't want to breathe it in. It's the main component of smog. So as we've seen with some other aspects, right, these have really changed over the last number of decades. Um, for air, we have for water, we've got like the Clean Water Act. For air, we have the Clean Air Act. We briefly touched on this when we were going through history uh, in the history section of the environmental movement. So the Clean Air Act of 1970, put forth by the United States Environmental Protection Agency, kind of started putting limits on how much pollution you could put out. Before that, it was disaggregated. States could put limits on things, but there wasn't a United States or federal regulation on how much an industry could pollute. So the Clean Air Act kind of put those regulations in place and allowed us to really start cleaning up our air. Now, again, normally I would show you this map. I'd like you to go look at it on your own. I'll have the link down below. We would typically look at this in class, but this is what air quality over the United States is right now. So it's a pretty interesting thing to go check out. So prior to the Clean Air Act of 1970, right, here's New York City in 1966, ripe with photochemical smog. Then there it is in 2018. So these bits of legislation are really, really, really impactful for trying to improve our air quality, and it's something that can be done. Um, sorry. But this usually comes on a country basis, right? It's not consistent over the entire globe. So places like China, Beijing, right? Um, really all over China have terrible air quality um, because there aren't these types of federal moratoriums on how much you can pollute. There have been some advances made, but for the most part, places like China and India, you don't have this type of legislation in play. See some more examples of it here. So I'll provide a link to this as well, to this article and this article. Dirty Air, How India Became the Most Polluted Country on Earth, and 22 of the top 30 most polluted cities in the world are in India. So obviously there's some problems that we need to address, and this is something that things like the United Nations try to address, or the one of the some of the premier environmental protection organizations, global protection organizations, try to address and come together and find ways to improve this. But unfortunately, a lot of it comes down to economic requirements, and it's hard to tell a country who depends on industry that's been exported. You have to, you can't run your industry the way that sustains a lot of the economy for your country because that's not fair. So it's something that we'll have to come together as really as people, as humanity, and try and come up with better ways to improve methods for this type of industrial activity across the world. It's happening in our own backyard too, kind of our own backyard. Louisiana. We mentioned Cancer Alley way early on in the class. Some of the highest rates of cancer in the country, particularly centered around a little town. It's been called Cancer Town, mostly because of these 150 petrochemical plants and refineries. Um, so Reserve, this little town here, often named Cancer Town, sadly, um, is nestled right in the middle of this corridor between New Orleans and Baton Rouge, where cancer rates are about 50 times higher than the national average, which is really concerning. And what's even more concerning is that there's an environmental justice story here as well, where there's widespread racial disparity in cancer rates. In fact, um, two bits here. First off, this was in November of 2019, so a little bit ago. Some things have changed since, but new EPA rules aim to reduce toxic emissions, but many Cancer Alley chemical plants don't have to change. So this is a concern because these people who are trying to get help aren't getting any help. Here's another one from just before that first article, so the 30th of October 2019, almost 4 years ago now. Welcome to Cancer Alley, where toxic air is about to get worse. Air quality has improved for decades across the United States, but Louisiana is backsliding. Our analysis found that a crush of new industrial plants will increase concentrations of cancer-causing chemicals in predominantly Black and poor communities. So there's an environmental justice and environmental racism story here that needs to be considered. There we go. So I want you to pause the video here and watch the second video link provided for this news article on Cancer Alley. And once you've watched this one, you can then go forth and do your concept application assignment 3 on Cancer Alley. You're just going to answer a couple very brief questions on why the town of Reserve stands out. So it should be really quick. It'll take you, once you get into it, it'll take you 5 minutes to finish it. So just testing your knowledge and attentiveness on the subject here. So again, check in. How do humans adversely modify the atmosphere? The first is by adding pollutants to it. The second is by adding excess carbon. And that's one of the big ones. More specifically, carbon dioxide, CO2 to our atmosphere. So if we look at this little bit here, right, we are breathing. And during cellular respiration, we basically have glucose and oxygen. Our cells are using both of those. And as they use that, energy is released, and carbon dioxide and water are exchanged, right? We breathe in oxygen, and through oxygen and sugar, glucose, we combine those, we have energy expenditure. Then what's emitted from us is carbon dioxide, CO2, and water vapor, H2O. And some of the ways that that's offset is obviously through photosynthesis. This, in simple terms, is what we call the carbon cycle, right? And we'll see some pictures of the carbon cycle here in just a minute or two. So first, let's ask ourselves, what are we doing to add excess carbon dioxide to the atmosphere? Well, some primary things. The first of them is by burning fossil fuels. You've probably heard this term a ton, but there's not necessarily a pure definition on what fossil fuels are. So what are fossil fuels? Well, here comes the third video. There's a few videos that we would have watched in class and talked about and enjoyed, but you're going to watch this video on Fossil Fuels 101. This will be the third link provided in the description down below. So go ahead and pause video, watch that video, and then come back to this one. So if you listened and you watched that video, good. If not, go back and watch it. But assume you did, we'll continue on. Coal and natural gas are some of the primary fossil fuels, and oil, petroleum as well. they form in some slightly different manners. In the video, you would have learned some of the ways that they form, really through heat and compression. So you need a lot of things above you that compress, and that added pressure adds heat, and that added heat kind of cooks things down, if you will. So we look at our description here. How was coal formed? We can look at this little example. This is from something done in North Dakota. You had 60 million years ago or so, you had a swamp, and things died off in that swamp, and then they got buried, and then more water came in, and you have this cycle of deposits and water moving back and coming back and moving back. And then over time, you bury that level that was a swamp more and more and more. And then as you add that weight, the top layers of water and dirt are packed down. The lower layers of plant matter are compressed under heat and pressure. They undergo a chemical and physical change that basically pushes out all the oxygen and leaves a hydrocarbon rich deposit, coal. Coal has a very high energy density. That's why we like to use it to burn and then get energy ourselves. Coal can be found relatively deep underground. It can also be found really near the surface. If you're driving through North Dakota and you're along some of the river valleys, you might even see coal exposures, low-grade coal exposures, right out of the hill slopes. So that's coal in a nutshell. Petroleum and natural gas, similar. Not necessarily the same, but they require the same thing, heat and pressure. Here you've got tiny sea plants and animals that died and were buried on the ocean floor rather than in a swamp. Then they were covered by sediment and rock over millennia, compressed over millions of years. Heat, pressure turns them into oil and gas. It's really the same kind of thing. We drill down to get to those now. So they're similar processes, but different products, if you will. So, okay, we've kind of answered what fossil fuels are. Why do we burn fossil fuels? Kind of gave it away a little bit, right? We burn fossil fuels for energy. So, what do we use energy for? Well, we use energy for a bunch of different stuff, right? We use it for transportation, whether that be travel, personal or business, hauling raw materials, hauling finished products, things like gasoline and diesel burning cars and trucks. I've driven through both of these. You should recognize the one in the top left. That's the Minneapolis-St. Paul metropolitan area. The one in the bottom right, San Francisco, Oakland. That's a mess to drive through. And I've been in that traffic before. Fortunately speaking, this wasn't my photo. Transportation, again, for diesel burning trains. Trains are really important for distributing goods across our country, and they burn diesel. Jet fuel burning airplanes, and fuel oil or bunker oil burning ships, like cargo ships or cruise ships. Again, more cargo ships. Now, I would invite you to pause the video here and go look at this site here and this site. They are really, really, really cool and very useful. And we would have done this again in class. Um, pardon me. So you will get to watch ships almost in real time. I think on the Vessel Finder one, moving across the oceans and waterways of the world in that Vessel Finder one. And then the ship map is a really cool story on how things have changed over the number of years and how ship traffic has changed and how transport has changed. It's a really, really cool link to go check out, so please do so. We also use fossil fuels for energy generation or electricity generation. We've talked about coal-fired power plants. We have natural gas-fired power plants as well. Coal-fired power plants provide about 23.5% of our energy, and natural gas-fired power plants provide about 38.4% of our energy. So why do we need to generate energy or electricity? Pardon me. This should be kind of an obvious one, right? Power things. Things like transportation, lighting, digital technology, and air conditioning, for example. Also for manufacturing and for agriculture. That's the third one. Things like gasoline and diesel burning farm implements, planting, applying fertilizers and pesticides, harvesting, all these things require energy from natural gas, petroleum, coal. What are we doing to add excess CO2 to the atmosphere? We're burning fossil fuels. Next, in our next session, this would have taken a lot more time, obviously, but there were multiple videos and discussions we would have had in class. This is the last slide. In the next lecture, we're going to look at some more of the aspects of how we're changing things by adding excess carbon to our atmosphere. So stay tuned for that. Make sure you do your class connection and all of the other things that you have going on. And we will see you back in class on Tuesday. Hope you have a great weekend, everyone.